the compressions and expansions are difficult, especially with what you've done in grade 11, because of the particular function you use in grade 11. This one, it's easier to see what happens. I know we looked at this last day, but we'll look at it again here. If you replace x with something, if you replace x with 2x, something gets compressed. Every point that was, like that point that was at 2, goes to 1. This point that was at -2 goes to -1. If you put a number smaller than this, again, maybe 0.25, it's going to be 4 times as wide. It does the opposite of what you expect, right? The reason being, if the original relationship was a 2 here, gives you 0, like this point right here. The original relationship on the original function was you put in an x value of 2, you get 0. All right? If now you're going to divide that number by 4, or in other words, multiply it by 0.25, before you apply the function, you need to start with something that's 4 times as big. All right? It does the opposite because the first thing you're going to do is divide it by 4, so you got to start with something 4 times as big. If you go back over here and if you go back to this side where we had a 2, if the first thing you're going to do is multiply the x value you start with by 2, you got to start with something half as big to maintain that same relationship. Okay, to get a 0, from the original function, you put in a 2, you get 0. From this new function, you put in a 1, you multiply by 2, and then you get a 0. Okay? I don't know if you can think about it like this as an analogy. Let's say you were trying to raise money for some kind of fundraiser. I don't know. They were going to build something for the school, some new wing of the school or gym or something like that. And they had to come up with the money for this. So let's say you needed $1 million to build whatever it is, right? So some company's going to build something for $1 million here, and you need $1 million, and out comes this new wing or gym or something like that of the school, right? Before you went to this company that's going to, whatever this is, before you went to that company that's going to build this, if you had a charity that said, or some sponsor that said, whatever money you come up with, we'll double it, and then, before you build the thing. So instead here now, if somebody says, instead, whatever money you come up with, we're going to double it, and then we'll give it to the company. If you times this by 2, right? So if this is X, how much money you need to build the thing. If this sponsor says, we're going to double the money you're going to put in, how much money do you have to put in here? You don't have to put, you have to put half as much, right? If someone's going to double it first, you have to put half as much. So if you change this to 2x now, this actually has to be half as much. That's why when you put a 2 here, half as much, something that was at 1 million is now only at 500,000, right? It's half as much. I don't know why a sponsor would do this, but if they were going to say, whatever you come up with here, we got to take half of it in tax, right? So whatever money is here, we're going to multiply it by a half. We're going to take half of it. How much money do you need to come up with now? You got to come up with twice as much, right? Before you accomplish that same thing in the end. So if you go back to this now, right? When you put a 2 in here, you only need half as much x to start with to accomplish the same thing, which is a point at 0, right? To get the same y value of 0, you need to start with something half as much. When somebody's going to multiply it by a quarter, which is, I guess, what I had before that. If you're going to multiply by a quarter, you got to start with 8 times as much before you get to that same point. It works the same way with y. We'll put that one back first. It works the same way with y here. If you put a number that is, I got this backwards here, but that's okay. If you put a number that is half in front of y here, it actually makes it twice as tall for the same reason, right? The y value has to be twice as big if it's going to be multiplied by a half. That's the same as if there's a 2 over here. And if you go down here, you get, whoa, too much. almost. You get the same thing, right? It works the same way with x and y. I don't know why I can't stop on the right thing there. Whatever, you get the idea. There. If there's a 2y, it's half as tall. If you're going to double the y value is going to be half as much to keep that same relationship. Okay? I'm going to pause this for a second here. If you're looking at expanding and compressing this thing, it's harder to see. When you had that semicircle, you could tell it's taller or shorter and it's wider or narrower. Like it was pretty easy to tell which way it was expanded or compressed. If I start changing this thing, what's happening? What's happening here? Oops, not quite. What's happened there? If you couldn't see this, like if you can't see the equation, what has happened to that blue one? How would you describe how it's changed? You could look at it as vertically expanding by 2, because this point you could think of as having gone to there, right? This point that is 4, 2 is now 4, 4. The y value, the y coordinate has doubled. Or you could look at it a different way, though. This is why it was such a hard thing in grade 11, because this particular shape, you can actually look at it when you make a change, like when you expand it one way, it actually is also compressing it the other direction just because of the nature of the shape. Because you could put a point here and say, no, instead it's actually, instead of expanding it by 2, it's actually compressing it horizontally by 4. Right? You could look at either way. So that's why parabolas are difficult and square root functions. This, if we see this equation, we know we're going to think of it as having happened which way here. If you replace y with 0.5y, you're expanding it vertically. You replace y with 0.5y, it doubles all the y coordinates. Okay? There's a way, if you wrote the specific equation for this square root function, there's a way to show that they're the same. That's kind of maybe a higher level concept at this point, and we'll come back to that later. All right? Because if we get rid of those points, and then we switch now to making this, I can make it go to exactly the same place, and I really don't know why I can't not do that, put points there. Let's go back to this now. I can make it look exactly the same way. If I change this, if I compress it horizontally, it's going to look the same. How do I compress this horizontally? What do I do? If I change this b, which is the number inside there, if I want to compress it horizontally, do I need a number bigger than 1 or smaller than 1 in here? If I want to compress it, I need a number bigger, right? Yeah. I need to make this, if I want to compress it by 4 times, I need to go out to 4 here. And that's going to compress it horizontally. That gives you the same, oops, come on. That puts it in exactly the same point it was before. Okay, for this particular shape, that compression horizontally by 4 is the same as expanding it vertically by 2. You need to be able to look at the equation and say what's happened though, okay? I want to show you one other thing here, which is, let's put this back to 1. I put a different function in here. These ones people have trouble with when the vertex of, if there's a shape that sort of has a vertex that's somewhere other than on one of the axes. This one has this vertex below here, and if I say I'm going to compress this or expand this, they kind of have grade 11 flashbacks, and they think of it as expanding or compressing from here. You're not expanding or compressing from here. If I change this a value, you'll see what I mean. Okay? If I make this 2 times as tall, it's expanding or compressing from the axis, right? Not from the vertex. If the vertex is already below, if I give you that function and say change it now, that expands and compresses from the axes. These points here are the ones that don't change. Okay? This point and this point, those points don't change. Everything else moves, right? Okay, if I give you a function that's already starting, if f of x is below that, it's going to expand like that. So kind of keep that in mind. The same goes for, the same goes for the other way here. Am I at 10 minutes here? I am. Well, we'll look at that other function in the next part.